Okay, and I did cover all of the things that you did say, Vincent, in the minutes that today that Go is going to be doing the universal payload for EDK2, and that we're going to cycle through each of the bootloaders and then follow that up with the configuration section.
Great, that sounds good. Thank you, Mickey.
Yeah, and I have a question for everyone. Does anybody have any opens that should be brought up today? Okay, no opens. Any other issues anybody wants to bring up? Okay, well, it's going to be a quiet and pretty quick meeting, it sounds like. Go, if you want to go ahead and present.
Ray today will present EDK2 bootloader. Next time for Slim boot, I will present that one.
Oh, okay.
Yeah, I will start my screen.
Okay.
Okay, so can you see the screen now?
Yes.
Yeah, today I will just give a very brief overview about how UEFI universal payload is being used in EDK2 bootloader, and I just prepared less than 10 pages, so probably it would be a very short overview. Okay, first, it's from EDK2 bootloader side, we think that the universal payload should be shared by different bootloaders, for example, core boot or EDK2 bootloader or Slim bootloader. And our vision is either every bootloader, they will prepare the data that's defined by the universal scalable firmware spec, and those data will be consumed by the universal payload, either the Linux one or the UEFI one, and each payload can boot to the OS. For example, the Linux payload can boot to Linux OS through the Linux boot related protocol, and the UEFI universal payload will boot to any UEFI OS, actually including Windows and Linux. And I also pick different color for different component. For example, the FSP, I choose the blue color because I want to indicate that it is board agnostic, but silicon specific. That means for each generation of the silicon, we may have just one FSP binary. But for the bootloader, we may have different instances for different boards, even for the same generation. And then for the universal payload, I just put a black color here, means they should be unified across different silicon or board. Okay, the next page. So
Ray,
yes, Dave.
In the previous slide, I think we discussed this before also, right? Is it a good is it a correct nomenclature to call it as UEFI payload, or is it actually an EDK2 payload?
Okay, I would call it EDK2. You mean payload? I would call it UEFI payload because it's going to support the UEFI boot.
Okay,
well,
because.
Yes, but Ray, you could do that with the DOS U-boot payload too, right?
I'm sorry. You mean U-boot can also support the UEFI boot?
Yes.
So it's officially support, or they are planning to do that in some tricky way? Or...
Oh, officially supported for over 5 years now.
Yeah. And Linux can also do UEFI. I think that was their plan to boot Windows, right? So they were planning to do OEM of instantiation of. Yeah, that's why I asked that
Well,
question. Go ahead.
that one's a little different, Ravi. They were planning on building a version of OVMF that looks like a Linux kernel and then k-execing OVMF.
Right.
Okay, so you prefer that, so we may just call that EDK2 universal payload or EDK2 payload.
I think that's a question.
Mm.
I'm not suggesting that strongly, but I think that may be more appropriate in my mind.
Okay. Okay. Yeah, in this page, yeah, by the way, thanks. Yeah, in this page, it explains what's in the universal payload. Actually, those are, so by in spec it defines that the payload is in ELF format, and for the UEFI version of the universal payload or the EDK2 version of the universal payload, we added 2 sections in the ELF binary. One section point to a standard structure that's defined by the spec, and in the structure it contains the identifier, spec revision, and all the necessary fields that can help the bootloader to identify what the payload is. Then we have another section. The other section contains the EDK2 generic drivers. For example, the DXC main or the PCI drivers, USB, HCI, yeah, all of those drivers. And we use obj copy to insert to create two ELF sections to put those binaries. Okay, and
again, Ray, sorry, sorry.
Yeah.
The bottom call out PE is the executable format used in Windows. Why are you? Why have you specified that? I don't see any PE in the.
Yes, correct. I just want to do some like background explanation. What is ELF? What is PE?
Okay, got it.
Yeah, on top of this page, just want to add, you can have more UPLD section, the yellow parts. Here give 2 section. That is common in the UEFI payload. You can add 1 or 2 more like sections. For example, you add some platform specific FV in another section. That is also supported, defined in the universal spec.
Okay, so in this page, it explains what the entry point of the ELF image look like. So it's very similar to today's. So it will accept a pointer to a hop buffer, a hop list, and the bootloader will prepare that. And now actually in maybe several weeks ago we had a discussion on which self-describing formats can be used to replace the hop, and the discussion is still ongoing. So for now, the spec and the implementation still aligns on hop. Okay, so this page explains when the universal payload binary, the ELF image, is built out, how it is integrated to the UEFI firmware. So basically, in UEFI firmware, we have several firmware volumes, and those firmware volumes will be together as a like 4 megabyte BIOS image or 8-byte BIOS image. And one of the FV binary originally it will contain some like maybe some EDK2 or non-EDK2 closed source UEFI components drivers. But if in UPL universal payload enabled platform, yeah, it's for example, it will have in this FV we may have 2 compressed FVs, and one of the FV will just contain a DXC core, and the DXC core actually it's not the original DXC core, it's the universal payload.elf, and the other FV may contain some other UEFI drivers. Yeah.
So really currently, for the EDK2, you build the UEFI payload. I mean, and then then you build the platform. How you could, you pack them together. You have another DSC definer in the platform. DSC.
You mean FDF?
Yeah, since currently in the EDK2 implementation, right? In the UEFI payload package, it will build the ALF image. That one already have one section included the FV UPL, right? So literally, you added the FV platform. This one, I assume it built from EDK2 platform somewhere. So now you compare them, you make it in a single FV. So how you made that change?
Yeah, okay, I understand the question. So you mean actually there are 2 choices for the image layout. One choice is like this. We have 2 FVs, one contain the ELF binary, one contain the platform FV. And the other choice is the ELF binary will contain another ELF section that that include the platform FV. So for this, yeah, it can work because from the below the side, it will just report the whole FVMan compact as a FV hub. So then in the DXC phase or the payload phase, the real DXC core will dispatch all the drivers pointed by the FV hub.
Yeah, universal payload, the ALF file was built from UEFI payload package, right?
Yes.
And the platform FV you build from another place.
Yes. Yeah.
So this, it is more nature of, if you put the FV platform in another FV, just added into universal payload ALF as a separate section, right?
Yeah, I agree. Yeah, yeah, we can also do in that way.
Okay.
Yeah, yes. Okay, so this picture explains how the flow looks like or how it works in a QMU platform, and you can click this link to look at the POC code. Okay, so for the actually with the universal payload concept, the whole bus binary will be divided to two parts. The first part is the EDK2 bootloader. The second part is the EDK2 payload. And for the first part, it will still almost execute as the ordinary EDK2 or UEFI firmware, but there are some differences. First, we will change some of the PI modules in the EDK2 bootloader to produce some necessary hubs. Those hubs are defined in the universal scalable firmware spec, and those hubs will be consumed by the payload. And also we put elf loader there because originally the EDK, yeah, the PI code just contain the P loader. It does not contain the elf loader. So we need elf loader. Then the elf loader will be encapsulated as a load file PPI interface. Then when the PI phase ends, the DXI peer will call the load file PPI to find the DXE call and jump to that. And in this case, it will find the payload as a DXE call and jump to the payload entry point. And inside the payload, we also have two small phases. The first is the payload entry. It will accept all the hops. It will maybe convert some of the hop to other hops that can be recognized by the DXE call. And after the conversion, it will jump to DXE call, and the DXE call will just execute as it does in ordinary EDK2 BIOS. It will just dispatch all the drivers, and then in the BDS phase, it jump to OS. Any question?
So when we build the UEFI EDK2 payload, there will be at least be two FV, one with the Dixie core, the other one with the platform drivers.
Yeah, actually here in this QMU POC, we just have a FV that contain all the PI modules. We call that a bootloader.
Right.
And the bootloader will just include the universal payload L file itself. No other DXC drivers, platform DXC drivers there. So we treat it as an ideal case that there is no platform payload.
Because in the previous slide, when Ga was also asking, right? So today, if you look at the EDK2 UEFI payload package, there are some platform agnostic drivers there, right? So are we planning to remove those, or so the way I originally thought was platform agnostic drivers will be part of that, and any platform specific drivers will be in the separate FV.
Yes, platform specific driver should not be in the universal payload. So maybe today we have some. I think you means the variable driver or SPI driver, those drivers.
Yeah, even some of those are already made platform agnostic, right? So like serial port driver and things like that, depending on the information consumed by the bootloader from the bootloader. These are all platform agnostic today, right? Whatever drivers you see in the EDK2 payload package in the open source EDK2, they are. So what I'm asking is, are we planning to remove that? Like now the UEFI payload package in EDK2 will only contain Dixie core? Is that what this picture shows me, or?
Oh no! This picture, the A, B, C driver are the generic drivers. Maybe I should put like a USB driver, PCI driver to say those. Yeah, those drivers are part of the universal payload even today.
Okay.
Yeah. It's they are not the platform drivers. Yeah, actually, in this, there are slight differences if the bootloader is core boot, because we know that core boot can also load the payload. Yeah. So the maybe not. The first difference is in core boot in the core boot implementation, they load another, we call that the Tiano payload. Actually, the Tiano payload is very similar to this payload, but it will contain I remember it contained the graphic driver, so the monitor will be on when payload starts, and also the payload will it will do the PCI bus enumeration, but the MMIO range, I mean, which range of MMIO can be used for PCI enumeration, the range information is guessed from the Tiano payload. I mean, guessed means they have some logic to try to figure out what is the top of the physical memory and what is the available MMIO on the 4G and what is So in universal payload we actually defined a PCI root bridge hub, and the payload expects the bootloader produce the MMIO information. Then payload will use the MMIO range described in the hub and allocate those MMIO for the individual PCI devices. Yeah, I think maybe previously when the system is a single, when the system is a single root bridge system, it might okay to let the payload to guess the MMI range for PCI bus. But if the system is a multiple root bridge system or multi-segment system, then they actually it's not possible for the payload to do a PCI bus enumeration for the second or third root bridges. And in fact, I also noticed that in Cobalt community, there's some discussion about this problem. Yeah, in this page, I just explained very briefly that how it works in a real platform. I mean, if we want to convert today's EDK2 BIOS to use universal payload and also the BIOS should provide the same functionality, the same behavior without any feature loss. Yeah, here so in Qmio case we just have EDK2 bootloader and universal payload, but in the real platform we have to move all the platform DXE or SMM drivers into a separate payload or FV. Yeah, and the platform payload will contain some silicon initialization, some SMM, RAS initialization, some code to produce ACPI SMBus table, and also it contains the platform specific UI, so that user can configure the options, and those options will be saved through the variable service, and then in the next boot, some of the variables will be consumed by the bootloader. Yeah, it's the real case in a real platform, and I also list some of the differences when comparing to the ideal case here. Yeah, first the bus enumeration is done in the payload side, but we know that for Slim boot and core boot, they are doing the bus enumeration in bootloader side. So we think maybe to align with other bootloaders, we can move the bus enumeration to EDK2 bootloader as well. The second part is for the platform payload, and we think that platform payload could be eventually removed because for those categories of code, for example, the late silicon SMM and the RAS, maybe they can move to the FSP, and for ACPI SMBus, maybe they can move to the bootloader. But yeah, maybe some of the source of the table, I mean, sometimes the bootloader even doesn't have the information that required for building the ACPI or SMBus table. So those information might be produced by FSP in a different format. And the configure UI, I mean the BIOS UI, the BIOS setup page, this could be moved to the bootloader, but yeah, it's still open that how we configure the bootloaders, because bootloader is before the payload, and how we configure the settings that belongs to bootloader, but maybe in payload phase we configure that, or maybe we just configure that in bootloader phase. Yeah, it's still open. Yeah, and maybe some platform, they're quite simple. They don't need a UI to configure. That's also possible. The other thing is a variable. The variable service means the UEFI variable service. UEFI variable service is a kind of service that provide persistent storage. For this part, maybe it can move to the bootloader, but how to implement that? Actually, there are many different choices, and we may also need to have more discussions on which one to choose. Yeah, and the goal is, even in EDK2 side, we'd like to remove the EDK2 platform payload. If those contain the platform specific modules, that will make the whole picture cleaner. And back to just now, Guo mentioned this payload can contain additional sections that have different FVs. So I'm also open to the option that maybe the ELF binary can contain a section, and that section may contain a platform payload.
Yeah, for EDK2, I think it is very, straightforward to build another FV, including platform-specific modules. And with this FV, you just need to, add as a section. So, but from the universal payload spec, right? We still follow the spec because the spec just mentioned you need to pass the parameter using hub, and for this hub, it also is defined by the spec. For this platform FV, and it also defined. It could be supported by the spec. So it is not conflicted. With the spec.
Yeah, I agree. I think maybe I should rephrase the words. The goal is not to remove the EDK2 platform payload. The goal is to remove the interaction between the platform payload and the EDK2 bootloader, or simplify the interaction. Today in this picture, it's a real case in a real platform. The bootloader will produce some information, some platform specific information in hubs, and also some dynamic PCDs are set in the PCD database, and those information are consumed by the platform payload. But imagine this platform payload, actually this platform payload and the universal payload, they together cannot be used by the core boot, because core boot does not produce those platform hubs, those platform PCDs. So maybe, yeah, we say that we can have like a feature payload, and in the feature payload it contains some drivers. Those drivers may just depend on the universal payload, but they don't depend on the EDK2 bootloader. That may be more make sense.
Yeah, we could put the advanced feature or something into the another payload called platform payload. If this feature, could be common for all the bootloader, literally for all the platform, so we can move to universal payload and change the spec and define and standardize the interface.
Yeah.
But for now, since it is not a common, I think, for core boot, Slim boot, you get to, yeah, we could use another FV, I mean, for these features.
So the other thing to consider, Ray, is at least for UEFI variables, the plan is to add a requirement for the bootloader to implement a UEFI variable service in the FSP 2.4 spec. So as part of that, I think it might not be impossible to consider the bootloader will probably have something like a variable services implementation before we get to the payload anyway.
Yeah, that would be great. That would make the picture cleaner. Yeah, and also I'm not sure if there is some discussion there. Maybe the bootloader can produce some metadata that describe the configurable options and also the user readable string for those options. Then maybe we can have a very generic UI payload that can parse the metadata produced by bootloader, and it can show a UI, and the user can configure can configure it here, and then those things can be saved in the binary layout that's also defined by the metadata. So then next time the bootloader can read those variables and consume them.
So are you thinking for like a policy update flow, like setup menu or something like that?
Yeah.
Oh, yeah. Yeah, I have some thoughts around that too. Yeah, that's kind of a mess right now, right?
Yeah,
Yeah,
currently the spec only defined one way from bootloader to payload pass the parameter, not defined how the payload, I mean, change the behavior to the bootloader. Yeah, if there is this kind of requirement, then maybe later we can try to standardize some method or yeah, how to pass back this configure blob.
Yeah.
Well, regardless of, the policy and the schema and all the other crap related to policy, at least I think we could probably put somewhere in the payload spec, like maybe a standardized definition of SMI triggers for variable reads and writes. And then you could make that like a codified thing that the bootloader would go implement as part of its SMM.
Yeah, I mean, if from bootloader side, the bootloaders can align they can align on maybe some of the verbal interfaces. Then, yeah, I think it'd be great to document it in the payload spec or in the universal scalable firmware spec.
Yeah, at least for Granite Rapids, we're planning on requiring bootloaders to implement EFI variables services. So I think that should be possible.
So since this is an open discussion, universal scalable firmware, whatever requirement we add will implicate all the existing bootloaders, right? So we need to be cognizant of that fact.
Yes, and I'm aware, Ravi.
Yeah. So,
Yeah,
like for example, the variable service. If you say that if you put a requirement that a bootloader has to implement that, then does that mean core boot and slim boot and U boot would have to implement them as well?
Yes.
Yeah, Ravi, I think we can provide that service. I mean, that service might be optional. So, for example, even in today, you hop, maybe you have one hop that define their interface, and also the hop contain the SMI communication buffer. And if that hop exists, so it means the bootloader supports such capability. So it means the payload can rely on the persistent storage service. Otherwise, the payload, just like it cannot save anything across boot.
Okay, yeah, if it's optional, that's one thing, because on the other side of the coin, the flip side of the coin is this is a universal payload spec. It's not EDK2 payload spec, right? So again, if Linux boot, they want to implement that, then we should, I want to be careful about putting certain requirements that will ultimately get rejected by some of the other community people, right?
Well, Linux boot's going to be a payload, right? So there wouldn't be a requirement for Linux boot to implement it. There'd be a requirement for core boot to implement it.
Right, but so like some of the earlier discussion said, we can put something in the USF spec requiring certain things to be done. Yeah, maybe if it is called out as optional and things, then it should be okay, I think.
Yeah, I think that's probably the best approach near term is optional. You embrace it if you want the richer functionality, but don't necessarily imply some additional business or platform requirements for these other bootloaders. But it's an opt-in for maybe the richer configured, the richer bootloaders. Yeah, I understand your concern, Ravi, and you're right. We don't want to have adoption of this imply they have to accrete some additional functionality that they normally would not have. So it's a fair point.
Well, I mean, it basically just comes down to whether the payload wants to expose an EFI services interface or not, right? If it does, then it's probably a good thing to have some way of saying, hey, this is the way the bootloader will provide that service, right? But I mean, if you're
but
going to
even
implement a payload that doesn't have EFI variable surfaces, then you probably don't care, right?
right, but even in that one, for example, the prescriptions around SMI, maybe people could do ring 0 runtime variables or something else. So it's there may be optionality or some alternate paths even within just even that use case. But yeah, no,
Oh yeah, I agree with that. I mean, it's just I guess it gets down to the do we want to allow callbacks from the payload back to the bootloader, and that's been a topic of heavy discussion, to say the least, right?
right,
The only reason I said SMI is just because it doesn't imply that, right?
Yeah, no, that's a good point. And yeah, the bigger one is you're right, that whole fire and forget or calling back is from a style of payloads and what level of coupling, and yeah, no, it's a good point.
This is my very last page. So if there is no comments, I will stop my sharing. My presentation is finished.
So you jinxed things, Ray, saying it'd be a short presentation. So I think it's good. I think it's a good overview, and yeah, I think probably doing a lap between all of the bootloaders. Core boot was last session, EDK2, and then if we can support a slim boot review next session, that'll at least have them all, in this sort of working groups view. And then some of the discussions we've had about consistency across the bootloaders and use cases. We'll sort of have all of the sort of understanding of the state of each one to help with that discussion around reconciling and what makes sense for the standard, for the specification. So I think this is a really, really good review. Thanks for doing it, putting it together, Ray.
Okay. Yeah, it was a good discussion. So does anybody have anything else they would like to add? Our next meeting will be April 6th. Okay, well, if nobody else has anything left to add, I will stop recording here and we can call it a meeting. Thanks, everybody.
Thank you.
Okay, thanks everyone. Thanks, Mickey.